Hello everyone, welcome to my channel. This is an educational channel dedicated toward filling you in on some great theories of everything and cosmologies, all-encompassing theories, magnum opuses from obscure authors, and anything else that I think could really help you with your life, your paradigm shifting, your holistic, can't quite think of the word there. Holistic development, or just satisfying your curiosity. And today is our 362nd video on the reciprocal system of theory from one Dewey Bernard Larson. And Mr. Larson lived in the 20th century, and he was a mining engineer out west in Portland. And about 1930, he had certain epiphanies about the nature of kind of like the periodic table, and he was kind of looking for an equation for the interatomic distance of elements and compounds, and ended up stumbling across some intuitions that were even beyond that scope, that were more revolutionary, more fundamental. And he pursued those, and eventually, much later in 1959, he put out his two fundamental postulates. These are concise explanations of how the world works. And from those postulates, he went into developing a theoretical universe through developing those postulates through a process of deduction and, expounding on them. Now, I have done about 15 videos on that process way back, maybe about 10 months ago, called The Outline of the Deductive Development of the Reciprocal System, where Larson goes through his thought process, all 165 steps toward developing a theoretical universe. And then in Larson's books, he kind of goes over his theoretical universe and shows how it stands up against some of the modern legacy theories. Not only the Newtonian universe, also the Einsteinian quantum mechanists, and so on. And it does appear to me, at least, that Larson's findings stand up quite well. So that is one of the main attractors for me. I just think that it's a kind of a beautiful theory. It's not foolproof. He doesn't have all the kinks worked out, and he died back in 1990. But some people have come along since then and have attempted to improve upon the theory and spread it out. And one of those people is Dr. Bruce Peret. We're going to be looking at one of the papers that he wrote today. But first, let's just get into Larson's postulates. Larson's first fundamental postulate, and the most important, is that the universe is composed entirely of one component: motion. Not matter, not energy, not force, but motion. And in fact, matter and energy and force are all just different varieties of motion. And for Larson, motion was the relationship between space and time. You can think of motion as basically a fraction, with space or time as the numerator and time or space as the denominator. Think, for example, of speed. The bicycle is moving at 17 miles per hour. That is 17 miles of space in 1 hour of time. Space over time equals speed. Or you could say, I dropped the ball out of the window and it fell at 32 feet per second per second. That is 32 feet of space in 1 second per second of time. Space over time to the second power. Acceleration. Or you could turn it around. Say, it took me 3 hours to push that thing 1 mile. That's 3 hours of time in 1 mile of space. Time over space, energy. And so on and so forth. Just to show that, all of our basic scientific quantities are forms of motion and can be expressed exclusively through time and space. Okay, now back to Larson's first postulate. The universe is composed entirely of motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. Okay, that is a reciprocal relationship between space and time. You can see that if you try to double the speed. You start out that the bicycle is moving 17 miles per hour. Well, let's try to double the speed. Well, then you can say the bicycle is now moving 34 miles per hour. Or you can say the bicycle is moving 17 miles per half hour. Either way is equivalent. You're doubling the speed either way. You can either multiply the space by 2 or you can divide the time by 2. That is a reciprocal relationship. And so that is, the first prong there of the first postulate. 2 reciprocal aspects, space and time. Then you have the 3-dimensionality. Now, another quality that that reciprocals have is that they, if you multiply them together, they equal 1. And also, if you have if one of them has a certain quality, the other one also has that quality. You can think of the fraction 1/4, and its reciprocal 4/1. They both, when you multiply them together, they equal 1. And when you look at their qualities, they're both the same. They both have 1 and they both have 4. But one of them has 1/4 in the order 1/4, and the other one has 4/1. So they have the same numbers, but they're in a different order. And that is similar with the second prong here of Larson's first postulate, that the universe is composed entirely of 1 component motion, existing in 3 dimensions. Now, what we know about space is that space is 3-dimensional. Now, we don't know that. I could definitely come up with some arguments that space is four-dimensional. Other people might be able to come up with other numbers, but in general, we think of space as three-dimensional. X, Y, Z coordinates, if you're graphing it out, and just the concept of volume, three-dimensional volume. And Larson is basically saying that, well, what I observe about space is that space has three dimensions. Therefore, since time is a reciprocal of space, time must also have three dimensions. So he posits the idea of three-dimensional time, what he calls coordinate time. And then he also has, and now this is kind of an understated part of the first postulate, and I wish that Larson would have included one more word in this postulate, which would be either scalar or progressive. The universe is composed entirely of one component, scalar motion, or entirely one component, progressive motion, because he just calls it motion, and he's but what the kind of motion that Larson is envisioning and that he's using in his theory is not the same kind of motion that your average person might think about when they're thinking about motion. He's actually referring to a pretty obscure kind of motion. It doesn't deserve to be obscure, but it really is, which is what he calls scalar motion, or what other people have called scalar motion. A scalar motion is a motion that has a magnitude, but it has no specific direction. You can envision a scalar motion using a balloon with dots on it. If you blow up the balloon, all of the dots are moving away from each other. But they're not really moving in any specific direction. They're just all moving away from each other. In fact, you don't even have to have the dots on it. All the locations, even in between the dots, are also moving away from each other. Everything on the surface of that balloon is moving away from everything else. This is a scalar motion. It has no specific direction. Really, it has all directions. And it's a scalar because it's based on the scale. The farther away that the dots are, the faster they are moving away from each other. The closer they are, the closer they're moving away from each other. Now, if you sucked in the balloon, then they would all be moving toward each other. But you do not get any direction out of that motion until you arbitrarily decide that one of those dots is motionless, and you assign that as the reference point. You can say, oh, well, this one's not moving. Now, once you do that, then you can start determining the directions of each one of the other ones. Now, another thing about this scalar motion is that, it can be modeled with a balloon, but it also has been observed in nature. In particular, looking through their telescopes, the legacy scientists have discovered that all of the distant galaxies are moving away from each other. And since they are not willing to go back on Copernicus and say that, our galaxy is at the center of the universe, they would also have to be saying that our galaxy is also participating in this motion. So all of the galaxies are moving away from each other. That is a scalar motion. So that is something that is observed. But for whatever reason, the scientists have not really embraced scalar motion as a bona fide kind of motion. It's just kind of an anomaly for them. But this is what Larson is building his whole system on, is scalar motion. He calls this clock time and clock space. The clock space is just what we were saying, like the surface of a balloon, and all the dots moving away from each other. Larson refers to this as clock space. Space is always getting farther and farther and farther apart. And his clock time is just like the clock. The clock is always getting later and later and later and later, but in no specific direction. It's always just a forward progression. And so he calls that clock time and clock space. Now we're much more accustomed to the idea of clock time than we are of clock space. But with that balloon analogy, you might be able to become a little bit more familiar with the clock space aspect. And then there's the discrete unit aspect. Each, both time, space, and also motion are quantized, meaning that they come only in discrete units. You have to have a full unit of space or time or motion before you have any of it. And if you have exactly 1 unit of space in 1 unit of time, remembering that space over time is speed, 1 unit of space over 1 unit of time is the speed of light. And Larson refers to the speed of light as unit speed. 1 over 1 equals 1. And this is the 1 of the reciprocal. When you multiply 2 reciprocals with each other, they equal 1. So this 1 speed of light is the background motion of our universe. It is always existing, omnipresent, and it is always and everywhere existing. And it is the 0 point, or the reference point. Larson calls it the progression of the natural reference system, the null point or neutral point, the state of rest of a universe of motion is to already be in motion. And that also creates half of a universe that is moving faster than the speed of light, and half of the universe is moving slower than the speed of light. Larson refers to these as the cosmic sector and the material sector, respectively. And the cosmic and the material sector are identical to each other on a general level, except that they are reciprocals of one another. So in the material sector, you have coordinate space and clock time. In the cosmic sector, once you cross that speed of light boundary, then you have coordinate time and you have clock space. So you have to invert whenever you cross this unit speed boundary. Okay, that's the basics of Larson's first postulate. His second postulate is just that the universe conforms to the relations of ordinary commutative mathematics. Its primary magnitudes are absolute, and its geometry is Euclidean. Now, Dr. Bruce Peret pushes back on a lot of that second postulate, including the idea of Euclidean geometry being most fundamental. He says that it is projective geometry, of which Euclidean geometry is just a subset. He also gets rid of the idea of commutative mathematics as opposed to just ordinary mathematics, and also gets rid of the idea of primary magnitudes. We will talk about that later. We've talked about it before as well. Now, getting into Peret's paper here, it's called the Lorentz factor. The Lorentz factor is the factor that time slows down in the relativistic equations as something starts to accelerate toward the speed of light. And ultimately, at the speed of light, time is supposed to be stopping. And he, this is the third installment of this paper, so if you want to hear this from the start, you want to go back a couple videos. But we're going to just read it from here. Now that he has this plus or minus y line to rotate, Larson adds an inward scalar rotation to the photon, moving the net motion to the -1, 0 coordinate with a single speed solution, creating the rotational base, whose net motion opposes the progression at the same velocity, the speed of light running backwards, that we call gravity, a very familiar concept. That is also, gravity would be the inward motion of that expanding balloon. All of the dots are moving toward each other. All of the locations are moving toward each other. But if you decide to make one of them a reference point, then you can start looking at, what are called gravitational fields between the different other points and your reference point. So it shows how the field is not a real thing. It is only the product of a reference system. Essentially, the Lorentz factor is just a fudge or kludge, hiding the use of imaginary quantities to describe a gravitational field structure. Imaginary quantities being I, J, and K, your imaginary operators that you may have learned in Algebra 2 class or whatever it was back in high school. They're all the square root of -1. In a fashion similar to the imaginary quantities used to describe electric and magnetic fields. This gravitational opposition to the progression is what gives the appearance of increasing mass, even though mass remains constant, since a heavier object, so-called heavier object, must have more gravitational pull and be harder to move. Now, this section is called the RS2 approach. The Lorentz factor is a one-dimensional solution to a two-dimensional problem, as is Larson's definition of the rotational base. However, the universe is three-dimensional, and as William Rowan Hamilton discovered, it takes 4 dimensions to solve a three-dimensional rotation. And that is why he came up with the quaternion, a 4-dimensional thing to solve a 3-dimensional rotation. The RS2 solution was to upgrade the complex plane of the corrected Lorentz factor and replace it with a quaternion. This, however, changes Larson's 2-unit approach of speed and energy into a 4-unit system of +1 ijk and ijk all multiplied together equals -1. This resulted in a far more accurate representation of the photon, changing it from a linear vibration to a quaternion rotation with similar characteristics, but including electromagnetic properties with a one-dimensional electric rotation, K, combined with a two-dimensional magnetic rotation, I and J. Since Ij equals K, I times J equals K, a birotation can be formed along electromagnetic lines using Ij J negative K, providing similar behavior to Professor KVK Nehru's original birotation model. This will be elaborated on in a future paper, but just wanted to note the RS and RS2 difference. Okay, summary. The Lorentz factor is the equation of a right triangle where speed is normalized for a unit speed of light. Ignoring the negative roots and velocities of the equation conceals the fact that the Lorentz factor is actually just a unit circle. Unit speed is the maximum speed the physical universe is capable of, expressed in the reciprocal system as the outward progression of the natural reference system. The minimum speed is negative unity, the inward motion expressed by gravitation. The default speed of the universe is unity. When a conventional object at rest is accelerated, what is actually happening is that the inward motion of gravity is being neutralized. A rocket isn't increasing its speed by thrust. The thrust is reducing the effect gravitation is having upon it, allowing it to return to the default speed of unity, that is the speed of light in all directions outward. It is impossible to accelerate an object past the speed of light in space because you are not adding velocity. You are reducing resistance. And once that resistance is gone, you are done. This is the situation in particle accelerators and why electromagnetic systems cannot accelerate a particle past the speed of light. All they can do is reduce the resistance, preventing the particle from moving at the speed of light. The circular form of the Lorentz factor produces similar results to Larson's construction of the rotational base. When the one-dimensional interpretation is upgraded to 3 dimensions, the linear vibration of the photon becomes a quaternion rotation possessing electromagnetic characteristics such as TE, TM, and TEM modes. Can't remember what those are. Electromagnetism, electric, magnetic, and electromagnetic. What the Lorentz factor comes down to is a device that is used to try to understand the inward, backward speed of light, motion of gravitation, similar to Ptolemy's epicycle description of the reversal of planetary motion. But when placed in the proper context, one can see past the illusion of mathematics and understand the underlying concepts. All right, that is the end of that paper, and my understanding of it is a little bit shaky, I must admit, but I will mull it over and see if I can get it to make sense to me. Definitely would consider it to be anti-scientific to just reject it out of hand, and to recognize that my understanding of the reciprocal system is not whole, and so I may not understand all parts of it all at once, and that it's a work in progress, and not to accept it without any evidence, but just to not reject it without any evidence, because normally people are going to be able to reject it by comparing it with what they already know. not recognizing that that is circular reasoning. So just let it in your head and be okay with being confused. And maybe in a little while, you'll get some more clarity about it. All right, well, thanks for tuning in today. We'll be back tomorrow with a new paper by Dr. Peret. This is RS2-109, his final paper in the series of RS2 papers, and it is called Dimensional Thinking. So stay tuned for that tomorrow, and other than that, have a great day.